All right, so there's going to be, I probably got like 2 examples of this, I think. This would be the most basic example of doing a problem with just the nth term stuff, or anything with the arithmetic sequence. Where the problem in guys, like with each day, like today and then the stuff on Wednesday, it's going to be straightforward in the fact that all the sequences you're dealing with today are arithmetic. Next class, all of them, the ones you're dealing with, are geometric. On the test, I'm not going to tell you it's arithmetic or geometric. You know, you should be able to, in test time, be able to look at it and tell which kind it is, and then apply the correct formula. Okay, I'm just bringing that in now, just so as you're doing the problems, kind of pay attention. All right. So all this is asking is find the 200th term once you write the nth term. Now, when it says write the nth term, that means use the formula that was there, which went an equals that plus. All right. This part right here just says plug in the first term, the common difference, and then just simplify it down so that you have one formula to simply find the nth term without having to do with this every single time. Okay, so again, this is the easiest one because they straightforward tell you that's the first term. I mean, starting with 15, so I know that's 15. Common difference would be whatever those two are subtracted, which in this case is minus what?
4.
4. Okay, so here's the thing. When you do this, I don't want you to leave it like that. Distribute, combine like terms, all that stuff. Get it down to where it's just one little thing. So you guys should have one that looks more like this. What? No, it's 19.
Yeah.
Okay. Now, the whole point of them doing that is so that if they ask you to find multiple terms in a row, like if I said find the 100th, the 200th, the 500th, all that stuff, you would just take whatever number they're telling you and plug it in for the end here. So like the 200th term would be 19 minus 4 times 200. Which, what's 19 minus 800?
700 minus 781.
781? So that would be the whole problem. This right here would be the nth term, right? That's a sub n. That right there would be your 200. Okay, that's the easiest one here. Alright, back to what I was going to say between this. With a problem like this, they don't strictly say find the nth term. Alright, so with a problem like this, where I just say find the 20th term, even on the test, I would assume someone's going to find out what the common difference is. Just go to the 12th term and start adding the common difference until they get up to 20. With a problem like this, that's fine. It's going to take you more time. Right? I don't want to do that. You do kind of want to stick with the formula. Now, but you do either way have to find out what the common difference is. If I'm giving you the 5th term and the 12th term, what do you think I'm going to do to find the common difference?
Find them and divide.
Find the what?
And I just made that up. I would
Subtract them?
Yeah, and then divide it by the amount that's in between. Like
Numbers. So like on the bottom, I can do 12 minus 5, right?
Yeah.
And that would be it. This is the value of the 12th term minus the value of the 5th term divided by the n equals 12. The 12 minus 5 is just telling me how many terms take up that value. So 32 minus 18 is how much?
14.
14, and then 12 minus 5 is?
7.
So I know my common difference is 2. So, like I said, someone's going to be able to find that, and then they'll just start at 12, find the 13, 14, 15. But it's not a necessity. If you go back and do this formula, guys, if you go back and do this formula, all right, you have to realize you have to go back and find the first term. It doesn't matter how you do it, but if you're doing the formula, or if this said write the nth term, you do have to figure that out first.
How do you find that?
I could use one of these, like I could do the fifth term is 18. The fifth term would be A1 plus 4 times 2, right? 4, that's the n minus 1. 2 is the common difference. So I know the first term plus 8 equals 18, so I know the first term is 10. Then I can go down here and plug in my 10. All right? And that would get me, oh, she's not in here, she's there. She's in so right, this will be what, 48? Is that right? Is that correct?
Yes.
19 times 2, 38 plus 10, yes, 48. Okay. Yes.
I don't get it. Yeah. Yeah.
4 times 2 is 8. Legit. 18 minus 8 is 10. I just took, this is the fifth term, so I did 8, the fifth term equals A1 plus 5 minus 1 times D. But the thing is, you know D is 2. The fifth term you know is 18, so I'm just replacing those. Okay? I could have done it with the other one off. All right. Now, next thing. Yes, you can do the same thing. You can count either way, it doesn't matter. No, the only time that's going to be a mess is if you're doing geometric, but even then you can. All right. The next part, guys, is the partial sum. Okay, these right here. Again, I'm not going to go through the whole deriving it right now, especially now. As much time left. But with the partial sums, guys, those are both the exact same formulas. Usually, it's easier to remember this one, and just to remind yourself, put an A1 there. The A always means A1, the first term. This is probably the one most people are going to try and remember, as opposed to this one right here. Just has the formula for the nth term plugged in, right? Because A sub n is the A1 plus n minus 1 times D. All right, and the reason it's 2 times A1 because you'll have A1 plus A1 plus n minus. It's just a matter of simplifying. So they're both the exact same formula. It's probably easier to remember it this way because you have to know that formula anyway. Okay? Now, all that you'll be doing with the arithmetic ones are partial sums, meaning you're only going to go up to a certain term. But you can't go on to infinity with these because the number would either get huge so fast that you just can't keep going to. It's not going to be a stopping point. There's no limit. So problems like this would be like find the sum of the first 10 terms, find the sum of the first 20 terms, 40, whatever. And it's just a matter of you remembering the formula correctly. Now, if you ever forget it, you can derive it. If you just found, like, if you start doing the partial sums like you would have done the last homework, like you find the sum of the first term, the first 2 terms, first 3 terms, and then see what the pattern is as you go through it. It is possible to come up with the formula on your own. It's just usually easier for people to try and memorize. Okay. Now, so like last time, I think I have 2 examples here.
Oh, go back to the second one.
Yeah? Yeah. All right. You good?
Yeah.
All right. I might have one. I don't remember if I got 1 or 2 examples here. We'll find out. This would be an easier one, again, because They give you the first term. You don't have to actually go back and find the first term. So you can just basically plug the numbers in as you would have. Now, the thing with the arithmetic, right, is the way the sum went, right? The sum was n, a1 plus an, 2. Correct? So if I'm actually doing the sum of the first 40 terms, that formula would go 40, my first term, my 40th term, divided by 2. First term they give you, right? That's A1 there. The only thing you have to do with the arithmetic ones is you have to find the nth term. Like you always have to find wherever it's stopping, the term where it stops. So you do actually have to go back in and use that formula. Alright, it's like usually a multi-step process. When we do the geometric ones, if you remember anything about them from algebra 2 stuff, geometric ones are easier. You don't have to have the ending term to do sums with that. Okay, so if I'm doing this, the first thing I'm going to do is find out what the 40th term is. Right, and to do that it would just be 2, that's my first term, plus 39 times, what's the common difference here?
3.
3. Right, because there's a difference of 3 between all of them. So what is 39 times 3 plus 2?
117. It's 117 plus 2. 190.
Well, 40 times 3 would be 120. Take 3 away and add 2. So I can just take these two numbers I've got now and plug them in. First term is 2. 40th term is 119. So 2 plus 119 divided by 2, and whatever the heck number that is, multiplied by 40. 400 what? Okay. But the thing you got to remember on all these, you need to know the ending term, you need to know the first term, all right, for all these sums that you're going to do. So if they don't give those to you, you do have to do the work to find them. Unlike the problem before that, like when you were just finding the 20th term, I didn't necessarily have to know the first term. I could have just found the difference and then added from there, like up to the 20th or wherever it was. Because it was pretty close to the 12th term that we were doing. Okay? Let's see if I got one. This will be the last one. Okay? Now, with this one, I'm giving you first term, I'm giving you the last term. Now I'm saying find the sum of them. Obviously you're not going to write these out.
I will.
Okay? If you do, have fun with that. No way I'm counting up by, what is that, 4? Right? Common difference here is 4. I'm not counting up by 4s until I get to 4 or 1, and then adding all those numbers together. You can if you want. Okay?
I will.
So that means for me to do this, basically I need to use these numbers that are there to figure out how many terms there actually exist. Okay, such as I know I know my formula again for the nth term goes a sub 1 plus n minus 1 times d. I know that's my a sub n, so I can technically take that, plug in 401. First term is 1. And I know my common difference is 4. Okay, I can solve that out. It's a basic linear equation. All right, if I were to go about solving this out, how would I probably do it?
Multiply the n minus 4.
Nah, I don't want to do any of that distributing.
Why not?
Just watch.
No,
Here's the thing.
Oh,
The idea is all I got to find is n.
Minus 1 from both sides and then divide both sides by 4.
Yeah, so for most of these, if you subtract the first term over and then divide by whatever the common difference is, that'll give you n minus 1. So you don't really need to worry about the whole distributing thing. Okay, because you'll have 100 equals n minus 1. So that means n is how much?
99.
No,
101.
99 minus 1 is 90. Okay? So with the, yeah, you get the same thing if you distribute it. It's just a little quicker if you do it this way. Okay?
I didn't even do that.
All right, now, and it only works because it's grouped. Because n minus 1 is grouped, I can do that. All right, so now the whole point of doing that is so I know how many terms there are in this sum. Because when I do the sum formula, the n goes on the outside. I wouldn't have had that. Although I do have the first term, I do have the last term. So I would have had everything in parentheses that I needed. I just didn't have this part when I started. So that was the whole work, was finding that part. All right, so that's 402 divided by 2. So what's 402 divided by 2?
201.
So 101 times 201. Big number.
20,301.
Wait, 20,301?